So in this case, we are going to consider the properties of some special matrices as we consider our syllabus. We have what we refer to as the identity, and there is another one which is a zero matrix. So these two, they are important. They have their special properties, starting with an identity matrix, all right? An identity matrix, actually, we were supposed to talk about this after we have done with determinants, inverse, and so forth. But in this case, let us consider it. It is given or can be represented by the letter I, this one, the capital letter I for identity. All right. And as a matrix, that identity matrix is 1, 0, 0, 1. That is the major diagonal. This one will be having 1, 1 like that. The minor will be 0. All right. So that is the illustration of what an identity matrix. So its properties now, it is in terms of a matrix. We understand it's a matrix, okay, but let's consider it, putting it in numbers as numbers. Identity matrix is just like one. This one is just like one in numbers. So we know that one times any number gives us what? That number. One times two, that's a two. So one times any number k, we are going to have that number. So it is the same if identity matrix is used or applied to as a one in numbers. It follows that where it is applicable in your multiplication, an identity matrix, when it multiplies any matrix, that matrix remains as it is. Okay? If you are to multiply by what? An identity matrix. So what I'm simply saying is that 1, 0, 0, 1 is an identity matrix. Let's say it is multiplying 2, 3, 4, 1. Okay, here we are talking about an identity matrix, which is a 2 by 2. So multiplying also what? A 2 by 2. So you know the multiplication concept as before we considered row by what? Row by column. 1 times 2, that's 2 plus 0 times 4, which is a 0. We move on to the second column. 1 times 3, that's a 3 plus 0 times 1, that's a 0. Second row to the first column, 0 times 2, that's a 0 plus 1 times 4, that's a 4. That same row, but to the second column, 0 times 3, that's a 0 plus 0 times 1, that's a 1, which we are going to have here as what? 2 plus 0, that's a 2, 3, 4, 1. Same matrix as we had before as a 2 by 2 matrix. So we can see that it is basically same as 1 in mathematics. 1 times any number, you get that number. So it follows that for this identity matrix, which is a 2 by 2 matrix, as we are to consider this a 2 by 2 matrix, if it is going to multiply another 2 by 2 matrix, we are going to simply obtain that matrix as it is. So that's basically what you have for an identity matrix. And for any other matrix multiplication, as long the issue of, the order allows you to multiply whatever that you're multiplying to by an identity matrix is going to give us that matrix as it is. All right. So that is what you have. And from where it was actually taken from, like I said, we're supposed to do this topic after covering the inverse of a 2 by 2 matrix. The identity matrix was actually taken from those 2 by 2 matrices when we multiplied the inverse and the original matrix. You are given a certain matrix, then you consider its inverse. All right. The inverse of a matrix is given by this presentation, a to the exponent of what? Negative 1. That means what? The inverse. So you have the inverse of a certain 2 by 2 matrix, then you multiply to that same matrix from that matrix where you obtained that inverse. That is where the identity matrix was obtained from. All right, so we are going to prove that one later on when we have covered the inverse of a matrix. So as we have the inverse to its original matrix, so it is the inverse to the what? The inverse matrix to its what? Original matrix. To the original what? Matrix. So if you multiply that inverse and its original matrix, you obtain what? An identity matrix, which is simply, you can write the letter I as we have there. So that is where it was taken from. We're going to talk about that later on. All right. But for now, you just need the properties. So we saw that it is in its multiplication, you obtain the original matrix by multiplying to any matrix inverse, the identity matrix times matrix B, you obtain matrix B, all right, whatever that you're given. Then the zero matrix also is special properties. In its properties, all right, it is just a matrix with a zero. If it is considering they are 2 by 2, all this is from what? A 2 by 2 matrix. So a zero matrix is simply given 0, 0, 0. They are just zeros. All right. So if it is a 3 by 3, 0, 0, 0, 0, like that. But for our syllabus, you're just going to consider what? For a 2 by 2 matrix like that. So its effect in numbers is just like using a zero. If you multiply any number by zero, you obtain what? A zero. So meaning to say, when a zero matrix is used in multiplication, the answer is going to be what? A zero matrix in multiplication. Take note, I said in what? In multiplication. In addition, in subtraction, add properly, but we know that 0 plus any number, you obtain that number. So 0 plus any matrix, you obtain that matrix that you are adding to the zero matrix, all right? But for multiplication, you obtain what? The 0, 0, 0 as it is, all right? So if you are having zeros, guys, just imagine you're multiplying by what? You're multiplying by 0. Whatever that you are having, you're going to multiply it by 0. So that is going to give you 0, 0 throughout, all right? So these are the properties that I want you guys to understand in your syllabus, and we're going to continue with these properties. So knowing them is important because let's say we are going to be solving simultaneous equations later on. If you understand these properties that I've indicated here, those simultaneous equations will be easier for you to solve using what? Using matrices. Because you already know that when I have an inverse matrix to the original matrix, I'm going to obtain an identity matrix. And the identity matrix, when it multiplies any matrix, I'm going to obtain that matrix that I'm multiplying by what? The identity matrix. So it helps you in calculations to make things easier. Those are some special properties. So we shall meet again, continuing with the same topic.